Welcome to today's video. Today we're going to be focusing on finding the slope of both parallel and perpendicular lines. We're going to show that mastery in class by scoring at least an 80% on the exit ticket. Hopefully you have the note sheet in front of you. If you don't, take out a separate sheet and we'll get you a fresh copy tomorrow. Now, when it comes to slopes of parallel and perpendicular lines, if two lines are parallel, first of all, that means that their slopes are going to be the same because these lines are never going to touch each other. No matter how far you extend them, the lines will never touch. If two lines are perpendicular, perpendicular means they meet at a right angle. So they're going to intersect each other and they're going to form a right angle. Their slopes are going to be what we call the opposite reciprocal. Now, reciprocal is a fancy way to say flip your fraction. If we were to multiply the two slopes of our perpendicular lines, their product is going to be -1. So that is one way you can check yourself. If you multiply the two slopes, do you get -1 out? Now, we're going to start with some basics. I'm going to give you some slopes. So M1 is -4, M2 is 0.25. We need to know, are they the same? Are they opposite reciprocal, or they are neither? Now, just a little reminder. These two straight lines, they mean parallel. And think of the word parallel has two L's next to each other. Well, that's the symbol for parallel. They never touch. The upside down T is your perpendicular because they are meeting at a right angle. So we made the symbols look like they're meeting at a right angle. If I look at number 1, -4 is the same thing as saying -4 over 1. 0.25, well, if I turn that into a fraction, that is 1 over 4. So if I look at my two fractions, they're obviously not the same, but we need to know, are they the opposite reciprocal? Well, if I take -4 over 1 and I flip it and take the reciprocal, I get 1 over 4. The opposite of being negative is positive, so in this case, they are perpendicular. And if you were to put this in your calculator or do it in your head and multiply them, -4 times 1 is -4. 1 times 4 is 4. So you do get -1. And that proves that they're perpendicular. So if you're not sure on the reciprocal, multiply them. See if you get that -1. Now, if we look at number 2, slope 1 is 0.75 and slope 2 is 6/8. Well, first I'm going to turn 0.75 into a fraction, which is 3 over 4. Now, 6/8 we can reduce down to 3 over 4. Our slopes are the same, so our two lines are parallel. Now, if we look at examples 3 and 4, again, we want to know, are they parallel, are they perpendicular, or are they nothing? They can just be two lines that intersect, but they don't have to intersect perpendicularly. To do this, we have to use slope formula. And actually, let's put it on here just in case you forget it. To find slope, it is y1 minus y2 over x1 minus x2. Or we can start with y2 on the top, but then make sure you start with x2 on the bottom. Either one will work. So if we look at number 3, if I need to find the slope of AB, I'm going to do 3 minus -2 and 3 minus 1. Well, 3 minus -2 gives me 5. 3 minus 2 gives me, or 3 minus 1, excuse me, gives me 2. Well, now I need to find the slope of CD. So again, I'm going to use the slope formula. I have 3 minus 1, and I have -1 minus 4. 3 minus 1 is 2. -1 minus 4 is -5. If I look at those two answers, they're not the same, so they can't be parallel. However, if I take 5/2 and I flip the fraction and take the reciprocal of it, I get 2/5. One number's positive, one number's negative, so they are opposite of each other. So for number 3, they are perpendicular to each other. They are perpendicular. Now, for number 4, again, we still need to find the slopes of A and B. We're still using the slope formula. AB, I'm going to do 5 minus 3. -4 minus -8. Well, 5 minus 3 gives me 2. -4 minus -8 gives me 4, which if I reduce down gives me a slope of 1/2. If I find the slope of CD, it is -4 minus -1 over 2 minus 8. negative 3 over negative 6, which again reduces down to 1/2. So if I look at my two slopes, they are the same. Since they are the same, my lines are parallel to each other. Anytime you have the same slope, the lines are parallel. And it doesn't matter if we're giving you points, if we give you two slope-intercept equation lines, if the slopes are the same, they are parallel. Now, you're also going to see problems where they give you a graph, and they're going to ask you to use the line and the point to find another point so that the slope is parallel. We're going to start with the line. And the thing we want to keep in mind, slope is equal to rise over run. So use the graph, find the slope. If you prefer to use the slope formula, you can pick 2 points from the graph. That'll work just the same if you plug it in. So in this case, I'm going to pick negative 4, 1, and I'm going to pick 2, 3. Now, if I do rise over run, it's just like we did in algebra. We want to count how many blocks do we go up and how many blocks do we go over. And keep in mind, if we're going up or to the right, my numbers are positive. If we are going down or to the left, my numbers are negative. So if I start at negative 4, negative 1, I went up 4, so that's positive 4, and I went to the right 6, so it's positive 6. So in this case, my slope is equal to 2 over 3. Now, the key word in this problem is parallel. Parallel means that they need to have the same slope. So now, all I'm going to do is I'm going to go to my point P that they give me, and I'm going to graph points that have that same slope. So it's positive 2, so that's telling me I'm going up 2, and it's a positive 3, so I'm going to the right 3. So if I start at point P, I can go up 2 to the right 3. That point works. Up 2 to the right 3. And we can keep going as many times as this graph will allow us. Now, we can also go down and to the left, because two negatives do make a positive. Down, 1, 2, 3. So any of those red dots will work as your points to make a parallel line. And if you look at the line that they give us and the line that our dots make, they are never going to touch no matter how far we extend them. If we look at example 6, again, we're still using the graph. However, now we need to find perpendicular. So I'm going to start the same way as I did before. Slope is still equal to rise over run, and I still want to remember up and to the right is positive, down and to the left is negative. And I know that's algebra, but write it to remind yourself, because we're not doing it in algebra. We're not spending the whole unit doing the same topics. Write it down. It's not wrong to write something like that down. Now, I'm going to pick 2 points on my line to find my slope. So I'm going to pick my x-intercept of 2, 0, and I'm going to pick my y-intercept of 1, 0, or 0, 1, excuse me. Again, I want to look. I go down 1 and to the right 2. So if I'm going down 1, it is negative 1 over positive 2. And make sure you pay attention. If you know the numbers and you can count the loops or you can count the slope, if I look at this line from left to right, it's going down, so it is a negative slope. Now, in this case, the key word here is perpendicular. So I need the opposite reciprocal. And that's important to keep in mind. If I take the opposite reciprocal, it means I need to flip my fraction, which if I flip my fraction, it becomes 2 over 1. My first slope is negative, so my second slope has to be positive. So I need points that have a slope of 2 over 1. So again, I'm going to start at P. 2 is positive, so I'm going to go up 2 over 1, up 2 over 1. And we can do it as many times as a graph. Now, I can also go down 2 and to the left 1, because 2 negatives make a positive. Down 2 over 1, down 2 over 1. And if we look, if we were to connect those dots, as best we can with a straight line, they meet at a 90-degree angle, so they are perpendicular to each other. Please keep in mind, we're still finding slope the same way we did in algebra. That part does not change. We just need to keep in mind that parallel slopes have the same slope, and perpendicular slopes are the opposite reciprocals. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.